All right, in this video we'll look at problem 3. It says let f be a scalar field and let capital F be a vector field and assume both of these fields are differentiable to all orders. Determine whether or not the given expressions are well defined. If an expression is well defined, state whether the quantity is a scalar field or a vector field. All right, so looking at part A, we have the del operator dotted with this scalar function f. Right, so now while the del operator is not a vector in the traditional sense because its components are those partial differential operators, it nonetheless does behave like a vector. And here we're dotting it with a scalar field, f. And does it make sense to take a dot product of a vector and a scalar? The answer there is no. So this is not well defined. And you can just see that there's a dimensional problem here, right? Because the del operator does have components, right? There's an I, j, and a k component, whereas the function f is just, well, scalar function f, right? So there's not a well-defined sense in which I can take that dot product. All right, moving on to B, we have del of the vector field f. Well, here, again, del is behaving like a vector, and capital F here is a vector field. And this is trying to take a certain kind of product. Now, if this was a scalar function, so in other words, little f, then that would make sense. That would just be the gradient of little f, and that would make sense in the way that we perform scalar multiplication. But here with a vector and a vector here, right, the products that we have defined between vectors are the dot product and the cross product. Okay, there's no indicated form of product here in relation to one of those uh, given products, and so this is not well defined either. Okay, how about part C? We have del of del dot f. Now, del dot f, this is the divergence of the vector field f. This produces a scalar field. And then does it make sense to take a scalar field and multiply it with this vector del? And here the answer is yes. This would really just be the gradient of this scalar field. Okay, so that would be behaving like scalar multiplication. And so this is well defined. And what would be the resulting expression? Would it be a vector field or a scalar field? Well, if this is a scalar field and then we're taking the gradient of it, the result is going to be a vector field. All right. Part D, we have del cross and then del cross F. Now, del cross F here, this is just the curl of the vector field F, and this produces a vector field. And does it make sense to take del cross a vector field? Yes, it certainly does. This is really just taking the curl of F. Right? It makes sense to take the cross product of a vector with another vector. So this is well defined. And what are we going to get out of this? A vector field or a scalar field? Well, if I take the cross product of two vectors, I get another vector. So this would be a vector field. All right. Moving on to E, we have del cross del dot F. And this is just the divergence of the vector field F. So this is a scalar field. Does it make sense to take the cross product of a vector and a scalar? No, it does not. So this is not well defined. Okay, and then lastly, we have part F, magnitude of del cross F. Well, del cross F, that's just the curl of the vector field F. This is a vector field. Does it make sense to take the magnitude of a vector? It certainly does, and so this is well defined. And what kind of field are we going to get from this operation? Well, here, you take the magnitude of a vector, you get a scalar. So here we're going to get a scalar field. And if you think about, what this is going to look like, when you take the curl of a vector field, right, you get another vector whose components are functions of x, y, and z. And then if I take the magnitude of that, that's just going to be the square root of the sum of the squares of those components. So that's going to give me a function of 3 variables. In other words, I'm going to get a scalar field out of that. All right, well, that's going to do it for this problem. Thanks so much.